Welcome to the class. We were discussing this topic on replacement, and I know I introduced certain heavy terminology yesterday and gave you a lot of detailed English to read for. But I hope the kind of example that we solved, it made certain part of the procedures very clear. I'll start with a little bit of a recap of the procedure that we have seen so far, right? So we are dealing with two cases. One where nothing else is given, and in one case there is a time period given for which you need the services for a particular equipment. This we have not dealt with so far, but in the other case, what we are trying to essentially do is ask or answer a question whether you have to replace a particular defender with a challenger in the year that is coming now, right? That's the question that you are trying to answer. So the procedure that we saw, since nothing else is given, you need to first estimate the economic service lives of both the challenger and the defender. We have also seen how to get the economic service life. You essentially plot the total annual cost, including the recovery factor plus the annual operating cost distributed over whatever the number of years you assume the economic service life to be, and you identify the economic service life N such that the total cost is minimum, right? Now, once you have calculated NC, ND, correspondingly, you can also calculate the total annual cost of each of the challenger and the defender. This information is sufficient for you to make a judgment whether this year you will need to replace it or not, right? If your defender's annual cost is lower than your challenger, you are not going to replace this year. That's the assumption. But if the challenger's cost is lower than the defender, you immediately replace and you assume that this challenger is going to be useful for next NC number of years, which is the economic service life of the challenger. And here the complete decision is already over. You don't need to proceed further for the question. But the case one, where the current annual worth, the total annual worth of the cost of defender is lesser than the challengers, then this year's solution is clear. Next year you need to repeat the study, and when you are repeating the study, if new estimates of market value and everything is available, new information about the cost and everything is available, you need to rely on that information rather than what was available in the original question a year before. Okay, so this is, and in second case, in the first case, if you find out that after 1 year, you have already reached the economic service life of the defender, in that case also, there is no option, but you need to replace because defender cannot keep on going, right? Now, I'll introduce some of the interesting things that could happen or that could seem contrastingly. And this theory does not capture all possible variations of the real world decisions that you will have, right? For example, you may be forced with a situation where your defender is following this kind of a cost structure. You are already at ND, but in the year ND plus 1, the total cost might still be cheaper than the AW of the challenger. You might have this kind of a situation very easily, that the alternatives are also so expensive that, or maybe because of some regulation change and everything, you are surpassing your defender's economic service life, but the challenger also is not a good alternative. In that case, what you do? And this is where this theory has limitation, because it forces you to retire your asset and use those only till the economic service life. You cannot use this theory anymore to make the judgment. What you do, I don't know, but essentially you cannot rely on this number, because there might be situation where your challengers have become so costlier that it may be cheaper for you to operate your inefficient defender 1 more year rather than replacing it. So you need to make a judgment accordingly. Concept remains the same. The annual worth and all those things remains the same. Next year, how much is the cost? But then the next year's decision should not be It should be only about perhaps the cash flow and the annual worth of that cash flow likely to happen in that next year, because there might be something else. So you all need to decide this. What do you foresee? Do you see that this situation that you are in, you do not expect any new challenger coming soon? Then you might make a long-term decision and a commitment to maybe replace the Defender with a new Defender, like a newer machine of the same kind rather than a completely new technology. All those things become viable in real world, and the real world is slightly more complicated than what we are seeing here. But even this was quite complicated, so I'm reiterating what we just learned yesterday. So coming back to this example, we saw this kind of an information given to you, typically very, very long paragraphs given to you. And first and the foremost challenge is to synthesize the information from this kind of a text. What exactly do you need to calculate this information? The answer is something that you need to worry about it. So for example, in this $15 million was not of a good number for us. Only the $70,000 at the beginning was of some interest to us. But was it really? No, because we were dealing with this equipment was original price 2 years ago. Now we are dealing with the current market value, which was 15,000 for the Defender and 50,000 for the Challenger. So even this 70,000 value we finally did not use. What has happened in the past has nothing to do with the current study that we are doing. Whatever happened with the Defender in the past cannot be the reason for you to make the decision now, or it cannot influence the decision that you are trying to make now. You only have to rely from here onwards what the future looks like. Only that part of the cash flow you have to consider in the analysis, right? So then I had showed you this terrifying looking Excel sheet, but I also showed you how to calculate, and all this is essentially what we have already seen. And once you do that analysis, you will find that for Challenger, the NC is 4 years, which is the economic service life of Challenger is 4 years. And the annual worth at the NC is this minus 19,000. Similarly, for Defender, the ND came out to be 3 years, and this AW at ND became 17,307. Why only 3 years? Because that was mentioned clearly in the question that you are not proceeding beyond 3 years, right? So within those 3 years, you chose the minimum one. Now, ultimately, we are making decision on basically on these two parameters. I can make it as a comma. Sorry. What's happening? Ultimately, you are making decision only on the annual worth of the Challenger calculated for economic service life of Challenger, and annual worth of Defender calculated at economic service life of the Defender. Why I am reiterating this? Suppose you choose only economic service life to only 1 year. In that case, you will see that year 1 cost only. Challenger is favored compared to Defender. In this next year, if you just consider the economic service life to be 1 year, then your Challenger is favoring the Defender, and you may make this difficulty because this is not representing the future expected or the most optimal where you could go, right? So do not confuse with these individual values. Of course, immediately in year 2, the situation changes slightly. The Defender starts getting favor, and then of course ultimately you are making decision on the economic service lives, and that's where the decision is clear that Defender needs to be retained in this particular case. Okay. Now, the second part of the question was, apart from all this information, now you need to, so the first decision that we made was you need to retain your Defender for this year. That's the decision we already covered. Now, some new information is available because every year you need to do the analysis. So the new information was that the value of expected market value of Defender is still 12,000, but it is expected to drop virtually nothing to 0, which they have given clearly, 2,000 next year and 0 after that. Right? They have also given you the annual operating charges, which is increased from 8,000 to 12,000 and 16,000 2 years out. In any case, beyond 3 years, you are not interested to retain this defender. So no cash flow further than that, right? At the same time, please notice that the key decision of this retrofitting of 16,000, you remember? Last year, in order to operate, we needed to upgrade the Defender by $16,000. That has nothing to do with the decision now. The decision is purely based on what is its market value at the moment. Doesn't matter if you had put some extra 16,000 just last 1 year and you still don't think that those 16,000 have been properly recovered or blah, blah, blah. You can't do that. Because ultimately what you're comparing the Defender and Challenger is that they are functionally equal, right? So that 16,000 in the last year has no bearing of what to do now. So in this case, actually, it might be a trouble, because if you had just thought about a year, clearly Challenger was being favored because you are having this extremely high cost. And on those numbers, you trusted and you thought that you will definitely use this Defender for at least 3 years. And only in that case, this decision made sense, right? But now the situation is totally changed. Now you have new information about the machinery and everything. And therefore, you are in a situation where this decision is likely to be reversed. Compared to the original one, you did not use this machine for 3 years. And therefore, you ultimately did not reach the optimal that you could have done. So you understand the fallacy that this kind of analysis can give you, because it follows the market price so diligently, like each time period you need to do, it might actually be prone to the current information that you have rather than the futuristic information that you could have, right? So again, one more variation of the problem in the real world, maybe not in the class, could be to make as rigorous calculation on the future market values and future predictions, how this technology is likely to go. Because if you're dealing with, for example, some very fundamental technology, which is like the core business of yours, it might have a huge impact on your company's entire portfolio, right? 1 or 2 here and there piece of equipment, maybe a large firm, does not matter. But for a huge company whose core technology is around that, it might have a huge impact. In this case, you could imagine they had almost 200 units. So 200 units is a mega investment. And here, this analysis would have definitely given you, in the hindsight, later if you analyze, it will give you a wrong answer. When you are doing it correctly. You are following the market value. But in the hindsight, this would have been a terrible decision, is what I would like to conclude at this stage, right? So you did a retrofit of an old equipment and your calculation showed that I am expecting it to work for another 3 years. But then after I had to retire ultimately only just after 1 year. So that retrofit was in fact more costlier, right? It actually required me to pay so much while I could have just taken that decision. So yes, you will be tempted to do these calculations. The theory is clear. How do you want to interpret the results depending on your situation? You have to analyze in what kind of decision making you are making. Because when we are doing this analysis, we are neutral. We do not favor either the Defender or the Challenger. But in company, you may not be neutral. You might be tempting to maximize your profit, and therefore you may need to do some extra work in order to estimate the futuristic market values, good estimation of them. Okay? Clear? Just the concept that I wanted to explain. Here, let me just show you the things. So, yeah, this cash flow series, once you understand that the past 16,000 retrofit has no implication at this stage, now you are doing essentially fresh analysis. And if you do that, you will find, since the Challenger, there is no new information available for Challenger, the same past values still hold true. So AWC, still the NC is 4 years and AWC for that is 19,123. In this case, now when you will do the AWD calculation, ND will come out to be 2 years and this will be 20,819. So now, definitely it does not make sense for you to retain the Defender. You need to replace it with the Challenger, right? Makes okay? Able to follow the example, and this is quite a comprehensive example. I'm glad that I could cover it in the class. Except for this, I have still not verified these Excel formulas, but I think it covers the entire theory that we have covered so far. Okay? Any questions? You will face these kind of dilemmas in this. Whenever I design new questions in this, people will come, sir, but the next cost of the Defender, even if you go beyond the economic service life, is cheaper compared to buying a new Challenger. So why should I replace and things like that? That's what the theory says. What you want to do of this information is up to you. If you're convinced that I will do this analysis slightly differently and I trust my numbers, go ahead and make a decision. This is the standard method of doing it. You may not need to follow depending upon what kind of situation you are. Okay? All right. So as I was explaining, we have covered the case where no information about your planning horizon was given, in a way that you are not defining for how long you really are going to use the equipment or whatever is the information. But in this case, there could be another alternative when you clearly define a study period, right? For example, I am looking for a 10-year planning horizon for my company. In that case, there could be a piece of machinery which is going to maybe require replacement in another 3 years, 4 years, or I could buy a Challenger right now which will last for 10 years. These kind of questions are also part of it. In the earlier period, you were clear that you were doing analysis till the economic service lives of the both. Now here, that is not the constraint. You are defining the constraint in terms of the total time period on which you need the service from all this machinery, right? So again, you have to do the annual worth calculation. Here you can also use present worth, but since we have been using annual worth, let's be consistent with that. And you have to do it for entire study period. Okay? And what you essentially end up making, I'm calling them scenarios, but these are not the scenarios what we saw in the Monte Carlo. Let me explain what I'm actually going to say, but give me a minute. For the time being, I'm calling them scenarios. But essentially, this interesting situation comes if your Defender's remaining life is shorter than the study period. Suppose you know that your current Defender can only last 2 years, while your study period is, let's say, 10 years. So you know that you will need to make a replacement decision. The question then there is, now or 2 years later, right? You definitely will have to make a decision, but whether now or later is the question that becomes. And this kind of problems we have solved to a little bit extent, but not extensively from a replacement perspective. So in this case, you have to also consider cost of providing Defender services from the end of its expected service life to the end of service period. So whatever happens in this 8 years period is also necessary to be included in this decision. You cannot make a decision only purely on looking at Defender's cost number, but you also have to include what will happen for the remaining 8 years when Defender is not there. Or if you retire Defender now, what will happen to remaining 10 years? Or if you retire a Defender 1 year from now, what will happen to the remaining 9 years? So the total cost of 10-year service, alternatives have to be equal, right? Alternatives have to provide service for 10 years. That's a requirement you have put. So when you're comparing for the entire life you have to consider. That's the main point, right? So, and again, this needs to be accurated and this needs to be part of the replacement study. So I'll also give an example. So essentially what you do is develop all viable ways to use the Defender and the Challenger during the study period. This is something, all viable ways is something what I'm calling as scenarios. Let me explain again, give an example in a minute. There may be only one option or many options, and the longer the study period, the more complex this analysis becomes. For example, you have, let's say your study period is 20 years, but you have a very rapidly, just let's take an example of a computer or a laptop. How long in these times do you think a computer is good enough, matching with the latest tech? 4 years, 5 years maximum. That's maximum, like even if it is working, but the software upgrades and everything will just kill your efficiency time, right? So no matter what you do. And then there are so many alternatives of a computer. And every year, same company launches 2 to 3 premium products in this category, right? So you can easily imagine how complex it could be to design that in 20 years, what all combination of defenders and challengers will I need to do in order to justify the full 20-year production services for me, right? So the more complex, the more longer, the more number of challenges and defenders you are dealing, the more complicated this problem can become. But because it becomes almost impossible to do this manually. You cannot keep on making alternatives and do the calculation. Of course, you can automate that easily in computer. Okay. So the AW values of the challenger and defender cash flows are used to build the equivalent cash flow for each option. Let me just describe a simpler way of all that English that is written there, right? So suppose if the study period is 5 years and the defender will remain in service 1 year, 2 years or 3 years. So either it can provide service for 1 year, it can provide service for 2 years, it can provide service for 3 years. Okay, that's the information that has been given to you. And you have to focus on the AW values for each defender retention period. In this case, there are 4 options. Let's call them W, X, Y, and Z. Okay. So what's happened? Option W, the defender retained for 3 years. So the remaining 2 years has to be done by the challenger, right? Option X, defender retained for just 2 years. So the remaining has to be served by the challenger for 3 years. Y, 1, 4, Z, 0, 5. Understand? So now we have covered for entire 5 years, we have all the combinations of defender versus challenger, how they are going to be combined. Now the story becomes simple. You have apparently values for each of them, and then you just make an AW analysis and compare out of these W, X, Y, Z, which option is better. Okay, so you are not worrying only single defender, or you are now dealing with the cash flow series of combined combination of defender challenger, and that combination could have multiple forms or options, you could call them. This is what exactly I was calling a scenario in the previous slide. Got the idea? Okay, so let's look at more English. This is again a little bit tricky example, but let's look at it. So L&T is preparing for a new 10-year track maintenance contract for high-speed railway project in India. Not real data, don't worry. An important piece of equipment for doing the same is the sleeper replacement machine. In high-speed railway, there is a sleeper tracks, you need to replace them. Actually not, but again, not real data, don't worry about it. The current system was purchased 7 years ago on a different contract. Following its reliable estimates, the current market value of the current system, which is the Defender, is $70,000. Remaining life of 3 more years, no salvage value, and annual operating cost of $30,000 per year. Okay. The only option for this system is to either replace now or retain it for 3 full more years. This information helps you to reduce the number of options, right? You can make a decision. I'm constraining. You cannot keep it for 1 year, 2 year, 3 year. Somehow the contract is either you can replace it now or you can replace it for 3 years. So there are practically 2 options. You need to just think of either 10 years from challenger or 7 years from the challenger, right? Essentially, why this could happen? Can you imagine any realistic situation how this kind of a constraint could arise? No? Contracts, guys? Anyone? L&T? No contracts experience? Yeah, could be that option. Sometimes also, when companies are dealing with such highly sophisticated equipment, they also have flexibility inbuilt in their original contract agreements. They are clearly saying that, hey, we will reevaluate the situation every 3 years, every 4 years, or whatever, whenever the information, and we want an option to exit in case this method is not working. So L&T, of course, maybe not owning this only for 10 years, they will not own such a piece of machinery. They might be leasing it from somewhere, right? So that could have a contract condition inbuilt that, okay, either we replace it now or we keep it at least 3 years. Maybe at the end of 7 years, there was an option for you to evaluate that, okay, now the market condition has changed. Does it even make sense for us to continue with this leasing agreement or not? This is called real options. You will have, again, I think in infrastructure financing course in management group, you might have more complex examples of that. But essentially, contracts also deal with this financial flexibility because you cannot predict the future. So sometimes the contracts have these flexible conditions that if the market conditions would change, it will allow the parties to take some alternative decisions at predefined points of time. That's called real option. And similar to what you also mentioned, it could also be related to operational challenges that either you build the capacity now or you will not have a 3-year period, you will not be able to have sufficient manpower to operate the other equipment or something. There could be many, many combinations, but possible. Okay, coming back. So, the only good challenger information is given. First cost is $7,50,000. Life is 10 years, salvage value 0, and AOC is $50,000 per year. Okay, the estimate for challenger system 3 years from now. This is if you buy Challenger today. This is if you buy Challenger 3 years later. Okay. First cost $900,000. Life still 10 years. Salvage value still 0. AOC is still $50,000 per year. Okay. Got the idea what is information is given? You have the current market value of the Defender. You have two possible options, whether to retire it today, whether to retire it 3 years later. Correspondingly, if you buy the Challenger today, you have the market value data available. If you were to buy the Challenger 3 years later, you have the market value data available. Okay? So, practically you can solve everything. Now, option 1 is Challenger for 10 years, that you are replacing it completely. Option 2, Defender for 3 years, followed by Challenger for 7 years. Okay? Here is an interesting assumption. Assume that the extra 3 years of the life of Challenger can be used for another project. Why do you think this assumption is important? So since if you assume that this project, this machinery is not going to be useful for any other project, essentially the 10 years worth of life's money you need to put in 7 years because you are going to use it only for 7 years, right? So that makes it little bit costlier because what you would have spent in 10 years, now you are supposed to spend only in 7 years, right? So that makes it little bit complicated. So the assumption is that we will neglect the cash flow after the 7 years and we might use it to bill on the other project, right? Otherwise, the project's cash flow becomes a little bit skewed. That's the only concern. And if a company is having multiple such projects, then it's fine. Okay, this will become a new Defender for another project and things like that. All this, and that's also again very much happening because these specialized piece of machinery always travel around multiple projects. So in those kind of situation, this assumption can have a significant influence on a project's cash flow. So you need to be careful whether it is really impacting one project's cash flow unnecessarily or you are able to easily distribute it across the projects, right? Probability of so if it is like a one-time specialized project that you have done and for that machine you are doing it, perhaps you may not want to keep it on your books. You may want to consider a leasing model because you really don't know what is going to happen with this machine after 7 years after this project is done. But if you are regularly doing such kind of projects, it might make sense for you to have this machine on your books and then use it in some other projects to justify its cost and distribute its cost. So yeah, not necessarily probability, but a risk perspective on that decision could be important for sure. Like nowadays, tower cranes are everywhere in India. Almost every cities you will just find it. But just 5-7 years ago, there used to be like a big piece of machinery to have on a single project. So a lot of the companies were working on the leasing model. But now a lot of companies just own them because they know that they will be able to mobilize it just next site right across in the same city. They don't even have to have a nationwide supply chain. But on the other hand, tunnel boring machines are really expensive piece of equipment, but everyone wants them. But nobody can keep them on their assets, right? Or their books, essentially financial books. So these are typically on the leasing models. So then you can justify only the leasing part and not worry about the full cost recovery of that particular asset, right? I think a few years ago, 2 or 3 years ago, almost 90% of the entire world's tunnel boring machines were in Singapore. I don't know what they are doing underneath the ground of the country, but essentially almost 80 to 90% of the tunnel boring machines in the world were in Singapore, deployed in Singapore. Since then, of course, the market has caught up. Now, India also is one of the largest live projects because of the metros and all. So, it can have a real macroeconomic impact also. Imagine the world's 90% supply is in one single hand. It can lead to interesting market dynamics also. And all this analysis becomes interesting then. So everything, all of these concepts, we are dealing with $20,000, $50,000 examples. But when you deal with $50 million, $100 million examples, a lot of these interesting examples come through and this entire method becomes quite interesting there. Okay. No stories. Come back to the analysis. So, this is your option 1's cash flow. You are replacing the Defender right now, 10 years straight away challenges. You are purchasing it for 750, annual operating cost 50,000 clearly given to you. Okay, pretty simple. Option 2. First 3 years, clear? 70,000 is the current market value for the Defender. For 3-year period, 30,000 value has been given to you. Right? Now, you need to buy the Challenger. At the end of year 3, you need to buy the Challenger. So, there will be a first cost of Challenger here, which will be somewhere about what? $90,000 per year. No, $900,000 per year. And there will be some AOC, which is given $50,000 per year. That's okay. But here, this is if you buy the original Challenger for at the end of year 3, you are essentially, the capital recovery factor essentially originally is for 10 years, right? But now you have to squeeze it for 3 years, and that's where a lot of transformations will happen, which we will look into. Okay. Assumption is that this remaining cash flow can be given to some other project, not our headache. So how do you do that is something that we are going to look for. Okay. Option 1, pretty simple. I think the easiest question that you have seen so far. 750 A by P, 10%, 10 years, 50,000 is the annual operating charges. The total AW for option 1 on a 10-year timeline is minus 172. Clear? Option 2, Defender for 3 years. 70,000, 30,000 P by A, 10%, 3. Essentially, this 30,000 cash flow series, I have converted to an equivalent P value. Now, this plus this 70,000, the 30,000 P value, I have to distribute for 10 years because that's the original, that's the total time period you are looking for. So, this entire value you have distributed using the A by P formula, 10%, 10. Got it? Mini 30,000, bring it to present, distribute to the 10-year cycle. Make sense? Alright. So then this part, only the defender's first 3 year equivalent at the entire 10 years is this cost, 23,534. Now comes the defender's follow-on part, which is you are buying a challenger and then you have to distribute it again for the 10 years, whatever period, right? So your capital recovery factor for original equipment was essentially this 900,000 A by P, 10%, 10 years, because 10 years is the life of the equipment, not the study period. 10 years is the life of the equipment, right? This value comes out to be minus 146,475. Okay? Now this plus the annual operating charge, you are first taking it to the future, which is 7 years, bringing back to the 10-year period. Got the idea? Capital recovery factor, because here's your salvage value was 0. So your minus original A and the whatever the capital recovery, whatever was the value, for 10 years period you got it. Now this value, which was originally calculated assuming 10 years, what is its equivalent for the 7-year period is something that you need to estimate. So you bring that value back to future value of worth of 7, and only that part you distribute back in the A by F for the whole 10 years. Is it making sense? Essentially, this AOC is fine. Option 2 we are dealing with. AOC transformation is pretty easy, right? You don't have to worry about it. Here S is 0, this P. So the capital recovery factor, original duration is 10 years, right? So you are essentially estimating some equivalent A value for these 10 years. Now I am only worried about this part of the series, because rest I am assuming that will be taken, that much part will be taken care by the other project. AOC definitely, but this much part also will be taken, that much capital recovery will happen in another project. So this 7 cash flows I need to distribute to the original project's 10 periods, which is the 3 period before you bought the challenger. So you convert this to a future value, then you distribute it back to the original 10 series. Is essentially what I have done. Got it? Look at the example again. You will be able to find out. It is logical. There is nothing illogical here. Essentially, you are not paying additional amount just because you operated it for 7 years instead of 10 years. Right? So what happens is the remaining value, whatever will be there, because if you are considering only 10 periods, the salvage value would reach to 0. But now since you are considering only 7 periods, the remaining salvage value will be going to the other project, and that becomes interesting for that project's headache, not our headache. Right now, not your headache. In company, still your headache. Because then you need to figure out where that money is going, what's that first cost, blah, 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 all those things you need to do. Okay? Here, I can make your life simpler. This is simpler if you're just worried about it. All right. So then the total annual worth of the option 2 becomes this value plus the only defender part that you had estimated. So that total amount becomes to 1,40,000. So, which is cheaper? Option 2 is cheaper. So, you would recommend that you retain the defender for next 3 years and then replace by challenger after 3. Okay? Good? Clear? That brings us to the end of almost 70% course content and the major part of the engineering economy side of it. From now onwards, we'll go more into the cost estimations for construction projects and things like that. But essentially, your engineering economy principles, all those kind of decisions that we are doing is done. There's one topic remaining. Let me know if you guys are interested to know about it. So far, we have dealt only with mutually exclusive projects. But there is another side of the story, which is the independent projects, in a way that if you invest in one, it does not necessarily bars you from investing in other. You can keep on investing as long as you have the money. Do you want to study this or not? Let me know. Not urgently. I will also require time. I do not have the ready-made slides, but if you want, I can cover it. If you don't want, we'll go into the cost estimation and slightly more theoretical part.